Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to go over a second problem involving Boyle's law. So this one is a little bit more complicated. It's a bit longer. It has two questions. So here a snorkeler takes a syringe filled with 16 milliliters of air from the surface where the pressure is at 1 atmosphere to an unknown depth. So he first has a syringe that is filled with 16 milliliters of air. So the syringe has a gas in it, air, right? And so that air is measured to 16 milliliters. And that's based on the air pressure, right? So the stronger the pressure, the more the syringe will be pushed in, and so the volume will be decreased. So the higher the outside pressure, then it's going to push in the syringe and decrease the volume of the gas in the syringe until the pressures are equalized, and then the syringe will stop. So the pressure inside the syringe is always going to be equal to the pressure on the outside. That's important to remember for this problem. So at the beginning, the volume of the air is 16 milliliters, and that is equated with a pressure, an outside pressure of 1 atmosphere. So that means that at this level, before you dive in, the pressure on the inside, the gas has a pressure of equal to 1 atmosphere pressure on the outside. So you know what the final, or you know what the initial pressure is in the syringe before you dive into that, to the water. So it's 16, volume of 16, and the pressure on the outside is 1 atmosphere, and that's equal to the pressure of the gas on the inside. And so the thing also to remember is that the pressure, the amount of gas in the syringe doesn't change. So you're not losing any air, you're not gaining any air. The volume of the air in the syringe at this unknown depth is 7.5 milliliters. So now the volume of the air in the syringe has gone down from 16 milliliters to 7.5. So the pressure on the outside has pushed the syringe in and decreased the volume of the air inside, right? Until the pressure of the gas on the inside is equal to the pressure on the outside. So that's what's going on here. And then the first question is, what is the pressure at the unknown depth? Okay, so let's just answer that question first. So our P1, the pressure that the air we're talking about, we're focused on the air inside the syringe. The pressure on the inside of the syringe is always equal to the outside. So in the beginning, the outside pressure was 1 atmosphere, so the pressure of the gas is 1 atmosphere as well. If they weren't equal, then the syringe would either push out or push in until that equilibrium is reached. So the pressure of the gas in the syringe is at 1 atm, 1.0 atm to begin with. And the volume, we have the volume, V1, the beginning volume at this known pressure is 16 milliliters. So make sure I have the Sig Figs correct. Yes, so 16 milliliters. So that's the beginning. You go down to this unknown depth, and now the volume has changed. So the V2 is now equal to 7.5 milliliters. And so they want to know, what is the pressure, what is the P2? And what are they saying? What is the pressure at the unknown depth? So they're talking about the pressure due to the water that you are in. But the pressure of the gas should be equal to that pressure. So if we find the pressure of the gas in the syringe at that level, then that is going to be the same as the pressure on the outside. So we need to find P2. And so since everything else is staying the same, they don't mention temperature, although realistically the temperature gets colder as you go down into the water. right? So temperature would have an effect, but they don't mention temperature, so we can assume it's constant. The amount of gas is constant, so we can use Boyle's law. And so once again, Boyle's law is P1 V1 equals P2 V2. So we solve for P2 again. So P2, if I divide both sides by V2, right? So V2 cancels out, and I get P2 is equal to P1 V1 over V2. So since I have these, I just plug them in. And so P1 is 1.0 ATM, and V1 is 16 milliliters, and V2 is 7.5 milliliters. Milliliters cancels out, leaves me with ATM for pressure. And so now all I need to do is get my calculator and calculate. So 1.0 times 16 divided by 7.5 equals, and I get 2.133. So 2.133, and that's atmospheres, okay? So we can check our answer to make sure it makes sense. So here we went from a volume, we decreased the volume, so we would expect the pressure to increase. So we went from 1 atmosphere to 2.133 atmosphere, so it went up, so it makes sense. Okay, so that is going to be the answer to the pressure. So the outside pressure has gone up to 2.133 atmospheres. Now let's check our sig figs here. So here I have 2 sig figs, 2 sig figs, 2 sig figs. So my answer should only have 2 sig figs. So I should cut it here. So my answer here should be 2.1 atmospheres. Now I'm not done yet. I have a second question. The second question is, if the pressure increases by 1 atmosphere for every additional 10 meters of depth, how deep is the snorkeler? So now what I can do is I can use, they give me a relationship. They give me the relationship of 1 atmosphere of pressure to 10 meters of depth. So I can write that as 1.0 atmospheres is equal to 10 meters. So I can use that as a conversion factor. So here I have my atmospheres, right? So now I can translate that. Now, here's the thing you gotta be careful of. What was the pressure that we started at? Right? We started at the surface. We started at the surface, right? So we started at 1 atmosphere, but now we're at 2.133 atmospheres. So the depth is going to depend on the difference, right? So I have to subtract out 1 atmosphere from the 2.133. So that's what I'm going to have to do. So we can do it here. So I have 2.133. I'm only allowed as for sig fig 2.1, but I'm going to use the 3.3. And I'm going to subtract out 1.0 atmospheres. So the difference in the pressure is going to be 1.133. And then because I'm subtracting, I'm looking only at decimal places, so I have 1 decimal place here, but remember this is my last sig fig is the 1 here, so that's actually 1 decimal place, so I'm only allowed 1 decimal place here, so I get rid of that. So 1.1 is what I have, but I'm going to keep the 3.3 in my calculation because I don't want a rounding error. So this is what I'm going to use in my calculation when I convert. So now that's the difference in the pressure. So now I can find the difference in the depth that I've gone from surface to wherever my unknown depth is. So I have 1.133 times over 1, and I'm going to multiply that by the conversion factor, 1 atmosphere is equal to 10 meters. So I'm going to put the 1.0 atmosphere on the bottom, 10 meters on top. Atmospheres, oops, atmospheres cancel out. Now I have meters. So now all I need to do is multiply the 1.133 times 10 equals, and I get 11.33. So that gives me 11.33 meters. And once again, I'm only allowed, for significance, I'm only allowed the 1 there. So this has 2 sig figs. This has 2. This has 2. Or, yeah, that has 2. We'll count that as 2 for every 10 meters. And so the final answer I have is 11 meters. So that would be the depth that I've gone down. So I went from surface and I went down 11 meters. And so that is the answer to the question. So that's how you answer this question. So we started with Boyle's law, and then we used our pressure. We took our pressure and we took the relationship they gave us to solve the depth problem. Thank you for joining me. I hope this was helpful, and if you liked it, please like the video, share the video with your friends, make a comment in the comment section. Make sure you subscribe to the channel and hit the notification bell so that way you can get notified of any new videos I put out. Thanks for joining me, and I'll see you next time.